The question is whether the use of pipe dope on wrench-tight threaded rigid metal conduit, or RMC, connections is acceptable, and if there are specific types of sealant that should be used for conduit work. NEC 300.6 states that threaded joints shall be made up wrench-tight. The use of pipe thread sealant is not specifically addressed in the National Electrical Code, but it is generally accepted as a good practice to improve sealing and prevent corrosion. While there are no specific requirements for conductive pipe thread sealant, it is recommended to use a type that is specifically designed for electrical applications. These sealants typically contain metal particles or other conductive materials that enhance electrical conductivity. Here are some recommended practices based on industry best practices and general electrical safety guidelines. Firstly, use a conductive pipe thread sealant on all threaded RMC connections. Secondly, clean the threads thoroughly before applying the sealant. Thirdly, apply the sealant sparingly to avoid over-tightening. Fourthly, tighten the joints securely with a wrench, but avoid over-tightening. Fifthly, verify the electrical continuity of the threaded connections after installation using an appropriate tester. Some recommended conductive pipe thread sealants for electrical applications include Ideal Pipe Joint Compound with Graphite, OT, Electri-Seal, Loctite 567 Thread Sealant, Rector-Seal No. 5, and Paramatics High Performance Thread Sealant. Using conductive pipe thread sealant on threaded RMC connections is an acceptable practice to improve sealing and electrical conductivity. While the NEC does not specifically address the use of sealant, it is generally considered to be good electrical practice. By following the recommendations outlined above, you can ensure safe and code-compliant electrical installations. The purpose of conduit systems, including RMC, is primarily to provide physical protection and a path for electrical wiring. They also serve as an equipment grounding conductor, providing a low impedance path for fault current to return to the source, which is essential for the proper operation of overcurrent protection devices like circuit breakers and fuses. When considering the use of pipe dope or thread sealant on RMC connections, there are several factors to keep in mind, especially concerning the electrical continuity of the conduit system. While the NEC mandates that threaded joints be made wrench-tight, the addition of a sealant can impact the metal-to-metal contact that ensures electrical continuity. This is where conductive pipe dope comes into play. Conductive pipe dope contains metallic particles such as graphite or zinc that enhance its ability to conduct electricity. These particles bridge the gap between the threads, maintaining a reliable electrical path even with the sealant present. Using a non-conductive pipe dope can introduce a layer of insulation between the conduit sections, potentially compromising the grounding path. In such cases, fault currents may not be able to flow freely back to the source, leading to slow or incomplete tripping of overcurrent devices and increasing the risk of electrical shock or fire. To ensure safe and effective installation, it's crucial to verify the electrical continuity of the conduit system after assembly, especially when using any kind of thread sealant. This can be done using a multimeter or a continuity tester to measure the resistance between different points in the conduit run. A low resistance reading indicates good electrical continuity, while a high resistance reading suggests a problem that needs to be addressed. In addition to electrical continuity, thread sealants also serve to protect the threaded connections from corrosion. RMC is typically made of galvanized steel, which is resistant to corrosion, but the threads themselves can be vulnerable, especially in harsh environments. Thread sealants create a barrier that prevents moisture and corrosive substances from reaching the threads, extending the lifespan of the conduit system. When selecting a thread sealant for RMC connections, consider the specific environmental conditions of the installation. For example, in coastal areas where salt spray is prevalent, a sealant with enhanced corrosion resistance may be necessary. Similarly, in areas with extreme temperatures, a sealant that can withstand those temperatures without breaking down is essential. The application of thread sealant is also an important factor in ensuring its effectiveness. The thread should be clean and free of any dirt or debris before applying the sealant. Apply the sealant evenly around the threads, making sure to fill all the gaps. Avoid over-tightening the connections, as this can damage the threads and compromise the seal. It's also worth noting that some manufacturers of electrical equipment, such as the obstruction lighting system mentioned, may specify particular types of thread sealant to be used with their product. Always follow the manufacturer's recommendations to ensure compatibility and proper performance. While the NEC does not explicitly address the use of thread sealant on RMC connections, it does provide general guidelines for grounding and bonding, which are relevant to this topic. NEC 250 covers the requirements for grounding and bonding electrical systems to ensure electrical safety. Proper grounding and bonding create a low impedance path for fault current, which helps to minimize the risk of electrical shock and fire. RMC, when properly installed, can serve as an equipment grounding conductor, but it's important to ensure that all connections are tight and that there are no gaps or breaks in the conduit run. In addition to NEC 250, NEC 300.12 requires that all raceways, including RMC, be installed as a complete system. This means that all sections of the conduit must be properly connected and supported, and that all openings must be sealed to prevent the entry of moisture and debris. This requirement is intended to maintain the integrity of the conduit system and to ensure that it provides adequate physical protection for the enclosed conductors. When installing RMC, it's also important to use the correct tools and fittings. Use a pipe wrench to tighten the threaded connections, and be sure to use the appropriate size wrench for the conduit being installed. Avoid using excessive force, as this can damage the threads and compromise the connection. Use listed fittings that are specifically designed for use with RMC. These fittings are tested and certified to meet industry standards for safety and performance. Do not use fittings that are not listed or that are not compatible with RMC. In summary, while the NEC does not specifically address the use of thread sealant on RMC connections, it is generally accepted as a good practice to improve sealing and prevent corrosion. When using thread sealant, be sure to use a conductive type that is specifically designed for electrical applications. Clean the threads thoroughly before applying the sealant, and tighten the connections securely with a wrench. Verify the electrical continuity of the conduit system after installation to ensure that it provides a low impedance path for fault current. Follow the manufacturer's recommendations for the use of thread sealant with specific electrical equipment. Adhere to the general guidelines for grounding and bonding in NEC 250 and ensure that all raceways are installed as a complete system in accordance with NEC 300.12. By following these guidelines, you can ensure safe and code-compliant electrical installations that provide reliable protection for people and property. Also, be aware of any local codes or regulations that may apply to electrical installations in your area. These codes may have specific requirements for the use of thread sealant on RMC connections. Check with your local electrical inspector to ensure that your installations comply with all applicable codes and regulations. Furthermore, consider the long-term maintenance of the RMC system. Regularly inspect the conduit for signs of corrosion or damage, and take corrective action as needed. Reapply thread sealant to any connections that show signs of leakage or corrosion. Keep the conduit system clean and free of debris. By properly maintaining the RMC system, you can extend its lifespan and ensure that it continues to provide reliable protection for the enclosed conductors. Remember that electrical safety is paramount. Always de-energize electrical circuits before working on them. Wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to perform electrical work, hire a licensed electrician. By following these safety precautions, you can minimize the risk of electrical shock and other hazards. In addition to the points already covered, it's crucial to address the specific requirements of the obstruction lighting system mentioned. Obstruction lighting systems, often used on towers and tall structures, have unique demands due to their exposure to the elements and the critical nature of their function in aviation safety. Firstly, consider the environmental conditions. Towers are often located in exposed areas subject to high winds, temperature extremes, and precipitation. Select a thread sealant that is rated for these conditions and can maintain its integrity over time. Secondly, ensure compatibility with lighting system components. Some lighting systems may have specific requirements for the types of materials that can be used in contact with their components. Verify that the thread sealant is compatible with the materials used in the junction boxes, fixtures, and wiring of the lighting system. Thirdly, address vibration concerns. Towers can experience significant vibration due to wind and other factors. Choose a thread sealant that is resistant to vibration and can prevent loosening of connections over time. Fourthly, consider the need for future maintenance. Obstruction lighting systems require periodic maintenance, including bulb replacements and inspections. Select a thread sealant that allows for easy disassembly and reassembly of connections without damaging the threads or compromising the seal. Fifthly, verify compliance with FAA regulations. Obstruction lighting systems are subject to regulations from the Federal Aviation Administration or FAA, which may have specific requirements for the installation and maintenance of these systems. Ensure that all materials and methods used in the installation comply with applicable FAA regulations. In addition to selecting the right thread sealant, proper installation techniques are essential for ensuring the reliability of the obstruction lighting system. Clean all threads thoroughly before applying the sealant. Use a wire brush or other suitable tool to remove any dirt, debris, or corrosion from the threads. Apply the sealant evenly and sparingly. Avoid applying too much sealant, as this can make it difficult to tighten the connections and can also create a mess. Tighten the connections securely with a wrench. Use the correct size wrench and apply the appropriate amount of torque to ensure a tight, leak-free connection. Verify the electrical continuity of all connections after installation. Use a multimeter or other suitable testing device to ensure that there is a low resistance path through all connections in the system. Inspect the system regularly for signs of corrosion, damage, or loose connections. Take corrective action as needed to maintain the integrity of the system. Keep detailed records of all inspections and maintenance activities. This information can be useful for tracking the performance of the system over time and for identifying potential problems before they become serious. Ensure that all personnel working on the obstruction lighting system are properly trained and qualified. Electrical work can be dangerous, and it's important to have the knowledge and skills necessary to perform the work safely and effectively. Finally, consider the use of additional protective measures to enhance the reliability and longevity of the obstruction lighting system. Apply a corrosion-resistant coating to all exposed metal surfaces. This can help to protect the system from the elements and prevent corrosion. Use weatherproof enclosures for all electrical components. This can help to protect the components from moisture, dust, and other contaminants. Install surge protection devices to protect the system from voltage surges. Voltage surges can damage sensitive electronic components and can cause the system to fail. Provide adequate ventilation for all electrical enclosures. This can help to prevent overheating and can extend the life of the components. By taking these additional protective measures, you can significantly enhance the reliability and longevity of the obstruction lighting system and ensure that it continues to provide safe and effective operation for many years to come. In conclusion, the use of thread sealant on RMC connections is a generally accepted practice that can improve sealing and prevent corrosion. However, it's important to select the right thread sealant for the application and to follow proper installation techniques to ensure electrical continuity and long-term reliability. When working on obstruction lighting systems, it's also important to consider the specific requirements of these systems and to comply with all applicable regulations. By following these guidelines, you can ensure safe and code-compliant electrical installations that provide reliable protection for people and property.